Hey guys, today we're going to talk about synthetic division. Synthetic division is a much more efficient and quick way to divide polynomials compared to the long division you've probably already learned. The only problem with synthetic division and why you had to learn long division in the first place is that synthetic can only be used when you're dividing by a linear factor. And a linear factor just means you're dividing by something that only has the power of 1 to the x term. So you're not dividing by anything like x squared or x cubed. You're only dividing by like x or x plus 3 or anything like that. So now let's look at our example where we see and we'll figure out how to do the synthetic division and just learn why it's so much more efficient than the long division. Alright, so this example we have x squared plus 2x minus 15 divided by x plus 5. And then we have our steps that we're going to do right here on the right hand side. So if you want to write these down, it might help you. It's just a good process to get used to when you're doing long division. Alright, so can we use synthetic division? Well, we're dividing by a linear term, x plus 5, so that means we can indeed do synthetic division. And if we can do synthetic division, we want to do synthetic division. So that's what we're going to do. First step, write the coefficients only, no variables, inside an upside down division symbol, leaving space underneath for another set of numbers. So that can be confusing, so let me just show you what it is. We're going to draw an upside down division symbol like this, and we're going to leave space for another set to be here, and we're going to write our numbers up here. And it says write the coefficients only, and we're using the top of the division, so we're going to do x squared plus 2x minus 15, but just write the coefficients. So the coefficient of the x squared term is 1, the coefficient of the x term is 2, and the constant term is just negative 15. So we'll write that there. Alright, that looks good. Now it says put the test 0 to the left of the other numbers outside of the symbol. Okay, the test 0 is just the divisor, and we set it equal to 0. So we set x plus 5 equals 0, and we get x equals negative 5. So that's our test 0, and we're going to put it right here to the left of the division outside of the symbol. Okay, so now it says take the first number inside the symbol and carry it to the bottom. So that's this right here, and we just draw an arrow and we're going to put it right here and put it outside. So now we're ready to do the synthetic division, and now is when you start the process that you'll repeat all the way down the line. So what you do is you take the number on the outside, the negative 5 here, and you multiply it by the number at the bottom, which in this case is 1. So negative 5 times 1 is negative 5, and you put it underneath the next number. So we'll put our negative 5 right there. And then you just add down the column. So what is 2 plus negative 5? It's the same thing as 2 minus 5, which will give us negative 3. And now you repeat what we just did again with the 15. Again until we get to the last column, which is 15 here. So now we'll do negative 5, but instead of multiplying by 1, we now multiply by negative 3. Negative 5 times negative 3 gives us positive 15. And again, we add down the column. So negative 15 plus 15, that gives us 0. And once we've gone all the way and we've gone all the way to the right hand side, we have nothing else to do. We're done. So this doesn't really look like an answer right now, but that's when we need to look at number step 7, and it says the numbers underneath the columns are the coefficients of your solution. Alright, that makes sense. And it says the largest degree will always be 1 less than the highest in the dividend. So what was the highest degree in the dividend? Well, that was x squared, so that was 2. 2 was the highest degree. And it's always going to be 1 less than 2, which is 1. So the highest degree of this is going to be 1. So we start on this side right here, and that's going to have x with a degree 1. So we're going to have 1 x to the first. And then as we go down the line, we just subtract the degree by 1. So it'll be negative 3 x to the 0. And that doesn't really look like we normally write our polynomials. So 1 x to the first, that can just be written as x. And then negative 3x to the 0, remember that anything raised to the 0 is 1, so we'll just have negative 3 times 1, which is just negative 3. So x minus 3 is how we would like to write that. And notice that this last column wouldn't have any x on it. It's just our remainder, and in this case it's remainder 0. So I could write r0, but that's not really necessary. So know that if the last number is 0, then what you have is a factor. Because going back to maybe algebra 1 or something, when you divide two numbers and the remainder is 0, so then you know it's a factor. So let's look at like 40 divided by 8. It equals 5, remainder 0. And because that remainder is 0, we can say that 8 is a factor of 40. And so when we divided x squared plus 2x minus 15 by x plus 5, we got a remainder of 0, so we can say x plus 5 is a factor of x squared plus 2x minus 15. So that's synthetic division. I hope that you see how much quicker it is than long division, but now we're going to do some of the applications of synthetic division and show what it's useful for. So here's a common example that you might see. It says, determine if x minus 4 is a factor of x squared plus 2x minus 8. On the right, I just wrote down some things to remember. It says if the last column has a 0 under it, that means the remainder is 0, making the term a factor. We just talked about that one. Then it also says be sure to put zeros as coefficients for degrees that may not even be listed in the problem. That's what we had to do for long division. Remember when we would have like x to the 5th plus x squared, we would have to write plus 0x to the 4th plus 0x to the 3rd. You just have to have those as placeholders. So we won't have any in this problem, but in my next example we do. So you'll see what I mean in a minute. So now let's just solve this synthetic division. And if we want to know if something is a factor, we just solve the division, and if the remainder is 0, we know it's a factor. So that's what we're going to do here. So we set up our upside down division symbol. We write the coefficients of the dividend term, so of x squared plus 2x minus 8. First of x squared is just 1, of 2x is 2 obviously, and then we just write our constant negative 8. And then we need to write down the 0, the test 0 to the left hand side. Well, x minus 4, if we set that equal to 0, we'd get x equals 4, so that'll be a 4 right there. And then remember, we start by bringing this down. The first number just goes down to the bottom, and it's a 1 in this case. Then now is when we start doing our multiplication and then adding down columns. So 4 times 1 gives us 4. 2 plus 4 gives us 6. 4 times 6 is 24. Negative 8 plus 24, that's going to give us 16. So I noticed that the last column, the part underneath the division symbol, is not a 0. That means that this is not a factor. So we've already answered the problem. It is not a factor because the remainder is not 0. So that was pretty quick. Synthetic division was able to do that really fast, and we answered our question. So now let's go on to the next one. The next one just wants us to divide the two numbers, the two polynomials I should say, of x cubed minus 1 divided by x minus 1. This is an example when we need to think about the second little tip that I gave, and that is that we have to put zeros as placeholders because I don't see an x squared term and I don't see an x term, but they have to be there because they went from x cubed all the way down to just a constant. So we need to remember that. So let's think about this. So x cubed is the biggest degree, so I'll put a 1 there because that's its coefficient. And then now x squared. How many x squareds do I have? Well, 0, right? So I have 0 x squareds, and then how many x's do I have? I have 0. Then how many, well, now it's just the constant, so then I just get to negative 1. So that's how I set that up here. And then the test 0 again is just x minus 1, set it equal to 0, we get 1, so we'll put that as the test 0. And now, remember the process, bring down the 1, and now you multiply. 1 times 1 is 1, 0 plus 1 is 1. Again, 1 times 1 is 1, 0 plus 1 is 1 again. Now 1 times 1 is 1, negative 1 plus 1 equals 0. So our answer, now you got to be careful again. It says, remember that we start the first degree of our answer, which is this one here, that's the coefficient, is going to be 1 less than the degree of the dividend. The dividend had degree 3, so our answer is going to have degree 2. So it'll be x squared plus x plus 1, and it has no remainder, so that means it's a factor. So I could write this as this times our divisor here, x minus 1. X minus 1. They can be multiplied and give us x cubed minus 1. So what we've done is we've essentially factored out this polynomial just by doing division here. So if we get a remainder of 0, we have almost factored it. We have factored it in a way because we figured out something that was a factor. I figured out that x squared plus x plus 1 was a factor and that x minus 1 was a factor. So I hope this was able to help. Let me know if you have any questions. I hope you realize that synthetic division is very useful and much preferred over long division. Thanks for watching.